Hello students, welcome to Lesson 2. Here we'll talk about basic oceanography terms and concepts that you need to be armed with for success in this course. One is the world ocean, which would be all of Earth's oceans and seas considered as a single interconnected entity. For many this is a foreign concept just to say world ocean, but it's one that oceanographers use regularly. Another aspect of the ocean is that it contains so much life that some scientists consider it to be alive. Here's a beautiful image, coral reef. You can see all of the fish, all of the corals. These are living organisms. What you can't see are all the microorganisms present within the water. So the question is the ocean alive? Is this really a valid concept? And I would give you a qualified yes to that question. Note, a single drop of ocean water can contain as many as 70,000 microorganisms. And here's an image showing just a few of those microorganisms. These are larger than many. Most of them are very small. They're called nanoplankton. So I'd like you to keep this in mind next time you are swimming, playing in the ocean, and you take a gulp of water. It happens. When you do so, you will ingest hundreds of thousands of organisms in the process. Most of these will do no harm. They'll pass right through your system, but on occasion, you can have some problems. So yeah, the ocean probably can be considered to be alive because it's so full of life. Also note that the ocean covers most of Earth's surface, 71%. Average depth, 12,500 feet. If you've been to the shore before, as you walk into the ocean, there it's just a few inches, few feet deep. So 12,500 feet, which is over 2 miles deep, informs us that the ocean is very shallow in coastal zones and therefore must be very deep when you get away from the shoreline. Also, basic concept, the ocean is an aqueous saline solution. Note, these terms may be unfamiliar to you. You'll be coming across lots of terms. It's a science class, and to a degree it's like learning a new language. So what does aqueous mean? What does saline mean? It's simple. Aqueous, watery. Saline is salty. So yeah, the ocean is watery and it's salty. With regard to salt content or salinity of the ocean, it's about 3.44% of the ocean. Typically, an oceanographer will refer to that as 34 parts per thousand, or ppt. This diagram to the left shows a kilogram of ocean water, and it's mostly H2O, water molecules, but you do have a wedge there, 34.4 grams of salt, that's the salinity. And then it breaks down that salinity content into the individual salts, the chloride, the sodium, and some of the other salts. We'll talk about this in detail in a later lesson. Another concept with regard to the ocean, northern hemisphere of the planet, it's the land hemisphere, because most of Earth's continental masses are in the northern hemisphere. So the southern hemisphere must be the blank hemisphere. Well, look at it, mostly covered with water. So these are basic and gross generalizations about Earth's surface, but they work for our perspective, looking at the global scale of the distribution of water and the geosphere. World is composed of 3 individual oceans. So how are they defined? One is by land masses. So here we're looking directly at the Indian Ocean. Continents A, B, C, and D, you should be able to name these continents. Let's give it a try. A would be Africa, B, Asia, C, Australia, and D, the southern continent, Antarctica. So you can see that together they help to define the boundaries of the Indian Ocean. We'll go into detail about ocean currents. They also help to define the edges of the oceans. So circled in blue there is where the Atlantic Ocean and the Indian Ocean have a chance to interact. And there are very strong shallow ocean currents, very different densities, that make it difficult for these oceans to mix. So these currents can also be used to define the edges of the oceans. Quick look at the 3 biggest oceans, the Pacific, by far the largest, and it's the deepest. And of note, its size is gradually decreasing. Why would this be? Topic for future discussion, something called subduction around the edges of the Pacific Ocean it results in the continents moving toward each other. So as that process plays out over a period of hundreds of millions of years, the Pacific Ocean is indeed shrinking. The Atlantic Ocean, it's our smallest and shallowest ocean. Its size is gradually increasing. So as the Pacific decreases in size, the Atlantic is increasing. Why is that happening? Running down the middle of the Atlantic Ocean, you can see that chain of mountains. It's called the Mid-Atlantic Ridge. This divergence or separation along the ridge is causing the continents to move away from each other, and therefore the Atlantic is getting bigger through time. Indian Ocean, it's the in-between ocean. One aspect that's of great interest is that it's gradually shallowing. This is due to deposition of sediment that originates from the Himalaya mountains. So the biggest mountains on Earth contribute lots of sediment to the Indian Ocean, and that's definitely a topic of interest for us down the line. Perhaps you've heard of the Arctic Ocean. It's still there, but it's now considered to be an extension of the North Atlantic Ocean, and so in general, we don't consider it to be an ocean in and of itself. So you can see with this image that there's quite a connection between the North Atlantic going past Greenland and right up toward the North Pole where the yellow dot is. So that's why the Arctic region is now considered just part of the Atlantic Ocean. Gulfs and seas. These are actually parts of the ocean. Somehow, through time, they become isolated from the main ocean body. Let's test your geography on seas. So here we're looking at North Africa in the bottom, then Europe toward the top. And I've numbered 4 different seas. Perhaps you can help me here. So number 1 is the Mediterranean Sea. It's isolated through the Strait of Gibraltar to the far left of the image from the Atlantic Ocean. Number 2, that's the Adriatic Sea. It's isolated from the bigger Mediterranean by Italy. Number 3 also starts with an A, the Aegean Sea, separated from the larger Mediterranean Sea by Greece. Number 4, the Black Sea, and it's pretty well separated from the Aegean Sea and Mediterranean Sea by a strait that pretty much closes it off. So that's a very different body of water. Let's look at a local sea, Gulf of California, Sea of Cortez. It's isolated from the Pacific by the Baja Peninsula as indicated on the image. And another example of a sea, Sea of Okhotsk, North Pacific Ocean, and it's isolated from the Pacific by a chain of islands and a large peninsula. So the Kamchatka Peninsula, the Kuril Islands, helped isolate that body of water. Who cares? Well, this actually is of great importance to oceanographers because we can see how different bodies of water will change as they're isolated from the open ocean. They'll wind up with different physical and chemical characteristics compared to the next door ocean. Sea of Cortez, for example, much warmer and saltier than the Pacific Ocean. Sea of Okhotsk, quite a bit colder and lower in salinity than the Pacific Ocean. So these are significant differences between these seas or gulfs and the neighboring ocean.